Welcome to Space Facts to Sleep For from Space Girl AI. Tonight, we'll journey through the cosmos, exploring the gentle wonders of our universe as you drift toward peaceful sleep. Let the calming cosmic truths wash over you, from distant starlight and silent galaxies to the patient rhythms of planets and the quiet dance of cosmic dust. Relax, breathe deeply, and let the serene vastness of space guide you toward tranquil rest. The Milky Way arches overhead as a hazy river of light. This soft glow is the combined shine of our galaxy's hundreds of billions of stars. Every star you see with the naked eye lies within this Milky Way band, each one a distant sun adding its faint twinkle to the night sky. Our sun and solar system drift around the Milky Way's center in a calm cosmic circuit. It takes about 250 million years for one full orbit, meaning the last time we were at this point in the galaxy's path, dinosaurs roamed the Earth. The sun moves at immense speed, about 828,000 kilometers per hour through space, yet we don't feel a thing. Space is so vast and frictionless that our journey is perfectly smooth and silent. The gentle galactic year is so long that a human life is just a brief moment in it. Over those eons, the Milky Way itself rotates and evolves leisurely. We live in a quiet, suburban part of this galaxy, about 25,000 light years from its crowded core, nestled among the stars of the Orion Arm. Out here, the starry night stays relatively constant and serene over millennia. When you gaze up, you're seeing ancient light that traveled years or centuries to reach your eyes. For example, the red supergiant Betelgeuse, the shoulder of Orion, is about 500 to 600 light years away. The soft reddish sparkle you see tonight left that distant star around the time of the Renaissance, hundreds of years ago. In this way, the stars we enjoy are messengers from the past, their light crossing the silent darkness for ages before gently illuminating our sky. The Milky Way appears as a milky band because we are looking edge-on into our galaxy's disk. With no city lights, this band becomes a mesmerizing, diffuse glow across the sky. It's a reminder that even in darkness, countless distant suns are steadily shining. Their collective light is faint to us, a subtle, calming luminescence rather than a harsh glare. Polaris, the North Star, sits almost directly above Earth's North Pole. To our eyes, it barely moves, a nearly fixed point in the sky. For centuries, it has provided a steady guide for navigators, shining patiently. Polaris is about 323 light-years away. Its constancy is an illusion of Earth's rotation, yet it gives an assuring sense of stability. On a still night, you can watch other stars slowly circling around Polaris, a majestic and predictable celestial dance that has persisted across human history. Far from city lights or up in space itself, starlight doesn't flicker, it shines steadily. The twinkling we see on Earth is caused by our atmosphere's shifting air. In the vacuum of space, or on a clear high mountain night, stars would appear calm and constant. This steady radiance can be soothing, as if the stars are quietly watching over us without interruption. Billions of other galaxies, each a vast collection of stars. The nearest large galaxy, Andromeda, is about 2.5 million light-years away. so distant that its light takes 2.5 million years to reach us. Under a truly dark sky, Andromeda is visible to the naked eye as a faint, fuzzy patch of light. Imagine the gentle glow you see left that galaxy before modern humans even existed. It's a quiet beacon from a far-off place, traveling across an almost unimaginable gulf of space and time. The Andromeda Galaxy contains roughly 1 trillion stars, yet from Earth, it appears as a modest smudge. This teaches us how vast space is. Even an enormous galaxy becomes a soft, tiny blur due to distance. Looking at it, you're seeing the combined shimmer of myriad stars blurred together. It's awe-inspiring and humbling in a peaceful way. To realize that faint cloud is actually a massive spiral structure, like our own Milky Way. Our Milky Way and Andromeda are drifting toward each other and will merge billions of years from now. But this slow dance is extraordinarily calm on the human timescale. For now, Andromeda simply hangs in the far distance, and nothing dramatic will happen for eons. Even galactic collisions are more like 2 giant clouds passing through each other. Stars are so far apart that they rarely hit directly. In the stillness of deep time, galaxies interact gracefully, the vast emptiness ensuring a gentle melding rather than a violent crash. The space between stars and between galaxies is almost completely empty, which contributes to the peace of the cosmos. When galaxies like Andromeda and the Milky Way eventually meet, their stars will mostly glide past one another in the great cosmic silence. Gravity will slowly remix them into a new, larger galaxy over millions of years. From our vantage now, we can just appreciate Andromeda as a serene, distant companion, the faintest wisp of light amid darkness. Every point of the sky, if you peer deeply with a telescope, contains galaxies upon galaxies. The Hubble space. Telescopes' long exposures revealed a deep field image where almost every spot of light is an entire galaxy, each with billions of stars. Yet these multitudes do not overwhelm the sky to our eyes. The universe's expansion spreads them so far apart that the night remains mostly dark, dotted by the relatively close stars of our own galaxy. This balance leaves us with a sky that is dark and quiet, with only hints of the immense cosmic community beyond, sparking wonder without any glare. Use clouds of gas and dust, often appearing as softly glowing patches in the night. In the constellation Orion, a faint hazy spot known as the Orion Nebula is visible to the unaided eye on a clear night. This nebula is about 1,340 light-years away and is a nursery where new stars are slowly being born. Through a telescope, it reveals a gentle swirl of pink and greenish light, the glow of hydrogen gas excited by young stars. It's a peaceful sight, as if nature is quietly lighting a cosmic nightlight in the darkness. In the Eagle Nebula, several thousand light-years away, famous tall columns of gas called the Pillars of Creation have been photographed. These structures look like serene ethereal mountains in space. In reality, they are cool clouds where stars begin to form. Despite the dramatic name, nothing explosive is happening at a human timescale. Over many millennia, these pillars are slowly eroding and seeding new stars. For now, they stand silently in the void, illuminated by the soft glow of nearby newborn stars. Not all nebulae are starbirth clouds. Some are the peaceful remains of stars that have shed their outer layers. When a sun-like star reaches old age, it can expel its outer atmosphere into space, creating a beautiful bubble of gas called a planetary nebula. One example is the Helix Nebula, often called the Eye of God Nebula, which appears as a delicate ring of color in the darkness. This is the star's farewell in slow motion. Not an explosion, but a graceful letting go of material that drifts outward to space. The core of the star then quietly cools into a white dwarf. Thus, even the end of a star's life can be a gentle, picturesque event, spreading faint light and enriching the cosmos for future stars and planets. To the eye, most nebulae look gray or pale, but long exposure images show they have soft colors, pinks from hydrogen, blues from oxygen. These colors are the nebula's own dim light. For instance, the Lagoon Nebula in Sagittarius is a calm lagoon of star formation that glows a tranquil rose hue in photographs. The reflection, nebulae like the Witch Head Nebula reflect the light of nearby stars, shining a ghostly blue. None of these clouds emit noise or sudden changes. They're steady, slowly evolving tapestries. Floating in the vacuum, they change only over thousands of years, making them perfect symbols of cosmic calmness and patience. Within these nebulae, tiny dust grains and gas clump together under gravity's soft pull. Over millions of years, they can form new stars and planets. It's a very slow, quiet process. Clouds condense in almost imperceptible motion. Our Sun and Earth likely formed in such a nebula billions of years ago. In a real sense, nebulae are cosmic cradles. Thinking of them can be comforting. They're the wombs of stars, wrapping nascent suns in blankets of gas and dust until they are ready to shine. Amid the stillness of space, creation happens not with a bang, but with an extended, gentle unfolding. Earth rotates once on its axis, giving us the cycle of day and night. To us, it's commonplace, but this steady spin is like a cradle rocking. It has been happening for billions of years, gradually slowing only a tiny bit over vast time. The transition from night to dawn and day to dusk is gradual and reliable, a natural rhythm that can be very soothing when you think about it. Our planet's rotation is so smooth that we don't feel it, yet it carries us around at about 1,670 kilometers per hour at the equator. This gentle motion brings the sunrise each morning in a silent, cosmic turn, and the stars each evening as our side of the world faces the quiet of space again. Earth orbits the sun at about 30 kilometers per second, completing one orbit every approximately 365 days. This orbit is nearly circular and very stable, changing only slightly over immense periods. We are essentially free-falling around the sun, held by its gravity in a delicate balance. The result is a graceful path that barely changes from year to year. As we circle the sun, we experience the slow progression of seasons, another reassuring cycle. Spring, summer, autumn, winter come and go in order, courtesy of Earth's tilted axis on that steady orbital path. It's comforting to know that as we sleep, our planet continues its quiet journey, and dawn will come as it has countless times before. All 8 planets move around the sun in the same direction, each on its own track, like a cosmic waltz. The sun's gravity holds them in this delicate gravitational dance, preventing them from flying off into space. Mercury swiftly loops around the sun in just 88 days, while distant Neptune it takes 165 years for one orbit. Yet despite these different tempos, the dance is harmonious. Planets rarely come very close to one another. For the most part, each planet peacefully minds its own orbit, following repetitive paths set in place eons ago. This stability means the solar system is a predictable, orderly place on the grand scale, which is a soothing thought when life feels chaotic. In the outer solar system, the planets move with majestic slowness. Saturn, famous for its rings, takes about 29.5 Earth years to complete one lap around the Sun. Uranus needs 84 years, and Neptune 165 years. A single season on Neptune lasts over 40 Earth years. Imagine a summer that long, but on Neptune, there's no rush as the planet's frigid blue clouds drift under a far, faint sun. These long orbital periods remind us that in space, time can be stretched out gracefully. Planets like Neptune and Pluto, which takes 248 years to orbit the Sun, move through epochs of human history with just one cycle. It lends perspective. The universe operates on timescales where a century is just a brief moment, reinforcing a sense of patience and endurance. Even at the edge of the solar system, the Sun's light persists, though greatly weakened. It takes sunlight 8 minutes to reach Earth, but about 80 minutes to reach Saturn, and a full 5.5 hours to reach Pluto. By the time sunlight gets out there, it's spread thin. On Pluto, high noon is only as bright as early twilight on Earth. A traveler standing on Pluto would see a dim daytime sky, with the sun just a very bright star, lighting a grayish landscape. This perpetual semi-dusk on Pluto is oddly comforting to imagine, an eternal, quiet evening light. It shows how space transforms even our brilliant sun into a gentle glow given enough distance. Beyond Neptune lies the Kuiper belt of icy bodies and comets, and farther still, the Oort cloud, a realm of drifting comet nuclei that extends perhaps a quarter of the way to the next star. Out there, the sun's presence is merely a memory, darkness nearly complete, with only that faint 5.5-hour-old sunlight and the distant stars. Comets in the Oort cloud spend eons in cold storage, barely moving relative to the sun. Occasionally, one gets nudged onto a long journey inward, but most will circle quietly for millions of years. The stillness of these distant orbits is profound. It's a part of the solar system that is more like interstellar space than the bustling inner solar system. Companion, orbiting us every 27.33 days, and showing nearly the same face to us at all times. This happens because the moon is tidally locked with Earth. It rotates on its axis in the same time it orbits us, so the same side always faces Earth. For thousands of years, humans have looked up at the same lunar features, the man in the moon, or the serene Maria Plains, a comforting constant across generations. The moon moves through its phases in a cycle of about 29.5 days, from new to full and back, a gentle waxing and waning nightlight. Each phase flows into the next predictably, casting silver illumination that has lulled people to sleep since time immemorial. If you were standing on the moon, even under the blazing sun, the sky would be pitch black. With virtually no atmosphere, the sky on the moon is always the color of space, black. There's no air to scatter sunlight into a blue glow like on Earth. Daytime on the moon is eerily silent and still. The sun shines, the ground is lit harshly, but the horizon blends into the blackness of space. And because there's no atmosphere, there's also no weather. The lunar surface is so calm that footprints left by astronauts in 1969 are still there, undisturbed. With no wind or rain to erase them, they could remain intact for millions of years. The moon's stillness is absolute, a true quiet that is hard to find anywhere else, making it a perfect mental image for peace. Far away, the dwarf planet Pluto has 5 moons. The largest, Charon, is so substantial, about half Pluto's size, that Pluto and Charon are tidally locked to each other. This means Pluto also shows the same face to Charon, just as Charon does to Pluto. They orbit a point in between them, like a delicate dumbbell in space. If you lived on one and looked at the other, it would hang in nearly the same spot in your sky at all times, a permanent fixture. This unique arrangement is a slow, cosmic duet, one rotation per orbit, forever keeping each other in mutual view. It's a wonderful example of nature finding equilibrium. In the dim light, 6 billion kilometers from the sun, Pluto and Charon quietly circle each other, locked in their private, perpetual spin, undisturbed for billions of years. Perhaps the most breathtaking gentle sight in the solar system is Saturn's rings. These rings are made of countless icy particles and pebbles, each orbiting Saturn like a tiny moon. Despite spanning over 280,000 kilometers in diameter, as wide as 3/4 of the distance from the Earth to the Moon, the rings are astonishingly thin, only about 10 meters thick in most places. If you looked at them edge on, they'd almost disappear. The particles rarely collide violently. Instead, they behave like a broad, flat disk of snowflakes, each minding its orbit. From afar, the rings look solid and serene, glowing gently in reflected sunlight. Up close, you'd find mostly empty space between ring particles. Saturn's rings are a cosmic lake of ice, ripple-free and calm, encircling the planet in a silent embrace. The giant planet Jupiter has dozens of moons, at least 95 known moons as of now, each contributing to a complex yet orderly system. The 4 largest, Io, Europa, Ganymede, and Callisto, are known as the Galilean moons. 3 of them, Io, Europa, Ganymede, participate in an intricate orbital resonance. For every orbit Io makes, Europa makes almost exactly half an orbit, and Ganymede 1/4, lining up periodically. This 4 to 2 to 1 resonance is like a gentle repeating pattern, a rhythm maintained by gravity. It causes a slight wobble in their motions, but overall it's stable and has likely persisted for eons. As these moons glide around Jupiter, they never collide or stray, each locked in its path. If you were floating in a spaceship around Jupiter, you'd see these moons continually appearing and disappearing behind Jupiter, like dancers taking turns on a stage, in an endless, silent performance choreographed by nature. Between Mars and Jupiter lies the asteroid belt, which movies often depict as a crowded field of tumbling rocks. In reality, it is so spacious that spacecraft routinely pass through without incident. The average separation between asteroids is on the order of millions of kilometers. You could stand on an asteroid and likely not see another one nearby, or it would appear as just a faint star-like point. Collisions are exceedingly rare. A 1-kilometer asteroid might collide only once in billions of years. So despite the presence of countless rocks, the belt is a place of great solitude. An asteroid there spends most of its time alone, sunlit on one side, dark on the other, rotating slowly in the vacuum. This contrasts contrasts sharply with the energetic imaginations of science fiction. Instead of chaos, the asteroid belt offers calm isolation. About space is that space is silent. In the near-perfect vacuum of outer space, there is no air or medium for sound waves to travel through. This means even dramatic cosmic events, a star's flare, an asteroid impact on the moon, occur in total silence if you were nearby in a spacesuit. The phrase, "In space, no one can hear you scream," is literally true. But flip that around, and it becomes, "In space, you will hear nothing at all." The loudest fireworks of the universe play out quietly. This profound silence can be oddly comforting. Imagine floating far from any planet, and all you hear is the faint sound of your own breathing in your suit. The universe around you is grand, but it's also as quiet as a midnight snowfall. Every day, without any fanfare, space sends a gentle rain of cosmic dust onto Earth. These are tiny motes from comets, asteroids, and distant stars. Thousands of tons of this stardust drift down to Earth each year, settling into our atmosphere and onto the surface. It happens so subtly, we don't notice. You might inhale a few cosmic particles with your next breath, or find them in the dust on your bookshelf. In a way, we live at the bottom of a very light cosmic snowfall that has lasted for billions of years and will continue for billions more. It's a poetic thought. The universe sprinkles us with a bit of itself continually, as gently as pollen floating on a breeze. Our bodies and everything around us are composed of elements that were forged in ancient stars. The calcium in our bones, the iron in our blood, the oxygen we breathe, all were created by stars over the history of the universe. Long ago, when those stars reached the ends of their lives, they released these elements into space, and eventually that material formed new star systems, new planets, and us. As the famous saying goes, we are all made of stardust. This isn't just figurative. Nearly every atom in your body, aside from hydrogen, came from a star's furnace. It's a quietly awe-inspiring realization. As you lie in bed, you might feel utterly earthbound, yet the very substance of your being has traveled across the cosmos. You carry a piece of cosmic history within you, calmly residing in a human form for a while, before returning to the stars in the far future. The sun doesn't only shine, it also breathes a very thin wind of charged particles into space, known as the solar wind. This wind is extremely tenuous, far less dense than even the emptiest air on Earth. And it flows outwards at high speed, creating an invisible current that all planets bathe in. Though it can cause auroras at Earth's poles when it hits our atmosphere, in space, the solar wind is a silent, ghostly breeze. It carries the sun's magnetic field outward, forming a protective bubble around the solar system called the heliosphere. Out at the heliosphere's edge, over 18 billion kilometers away, the solar wind finally slows and merges with the interstellar medium. The image of this is soothing. Our sun envelops us in a gigantic, gentle cocoon as we travel through the galaxy. Within this cocoon, the planets and comets surf the solar wind in near silence, like driftwood carried on a vast, calm sea. Everywhere in the universe, in every direction, there is a very faint background light, not visible to our eyes, but detectable with radio antennas. This is the cosmic microwave background, the cooled remnant of the universe's birth. It's only 2.7 degrees above absolute zero in temperature, essentially a uniform whisper of heat left from the Big Bang, now stretched into microwaves. The CMB is remarkably smooth and same in all directions, to only tiny variations, bathing the cosmos in an incredibly subtle glow. You can think of it as the universe's baby picture, a gentle wash of light that has been traveling for almost 13.8 billion years. It's hard to find a more serene concept. This light has been coursing through space since long before Earth existed, steadily fading and reddening, and now it's just a dim, cool background hum. When you tune an old TV set or radio to static, a portion of that static noise is actually this ancient signal. The universe has its own lullaby, and it's been playing continuously for eons at a volume just above silence. Comets are like the nomads of the solar system. Most of the time, they dwell in the distant outer regions, the Kuiper Belt and Oort cloud, as dark, frozen balls of ice and dust. A long-period comet may take thousands or even millions of years to complete one orbit around the Sun. In the Oort cloud, a comet might travel so slowly and so far out that the Sun is just a faint star among others. Ages pass in deep freeze and silence. Only rarely does a gravitational nudge send a comet inward toward the Sun, where it briefly sprouts a luminous tail. For example, Halley's Comet visits the inner solar system every 76 years, spending the rest of its time far beyond Neptune in quiet darkness. So, when you think of comets, envision them in their default state, drifting quietly in the outer void, like ancient snowballs caught in an endless, tranquil orbit, until destiny calls them inward for a short appearance. Humanity launched a small spacecraft named Voyager 1 to explore the outer planets. Decades later, having accomplished its mission, Voyager 1 just kept going. Now it is over 15 billion miles from Earth, the farthest human-made object in existence, traveling in the space between the stars. Out there, Voyager 1 is surrounded by nearly perfect silence and darkness. It cruises at about 17 kilometers per second, but there is no air to whoosh past it, no friction, no sound. Occasionally, it still sends a faint radio signal home, which takes over 21 hours to reach us one way at light speed. Otherwise, Voyager 1 is alone in the interstellar void, drifting farther year by year. It's comforting to think about this little hardy probe coasting calmly through space, like a bottle tossed into a gentle cosmic sea, carrying a message from its creators. Attached to each Voyager, 1 and 2, is a golden record, a phonograph record made of gold-plated copper. It contains a selection of sounds, music, greetings in many languages, and images from Earth, intended as a time capsule or greeting to any extraterrestrial finder. Because space is so empty, these records are expected to last 1 billion years or more without significant erosion. They silently ride along with the Voyagers. Imagine Bach's music, whale songs, a mother's kiss recorded in sound, the crackle of a fire, all floating through the galaxy on a disk, unheard until perhaps someone finds it eons from now. The thought of this golden record spinning through interstellar space is deeply poetic. Humanity's peaceful hello, carried by a messenger that will outlast our civilization. It's a reminder that amid the vast quiet, we have projected a friendly voice, one that might one day break the cosmic silence if received. Voyager 2, twin to Voyager 1, also launched in 1977, took a grand tour of the outer planets, then continued on. It is now in interstellar space as well, more than 12 billion miles from Earth. Both Voyagers have passed the heliopause, where the solar wind's influence wanes and interstellar space begins. As Voyager 2 traveled, it gave us serene views of Uranus and Neptune, pale blue-green globes suspended against blackness. Now Voyager 2, like its sibling, is coasting quietly. With each year, the environment around them grows more unchanging. The spacecraft no longer feel the solar wind, just the faint pressure of the galactic medium. If alien astronomers ever intercept them, they will find two quiet emissaries, long dormant, after their power runs out in the 2020s or 2030s, carrying the golden records and the story of a species that once dreamed and reached out. Before Voyagers, Pioneer 10 and Pioneer 11 were sent on similar escape trajectories out of the solar system. Pioneer 10, launched 1972, was the first to cross the asteroid belt and later became the first craft to travel beyond Neptune. It carries a simpler message than the Voyagers, a gold anodized aluminum plaque engraved with figures of a human man and woman and symbols to show where it came from. The pioneers are no longer contactable. Pioneer 10 sent its last signal in 2003. They too are drifting endlessly. Pioneer 10 is headed toward the star Aldebaran in Taurus, though it will take over 2 million years to get remotely near. These spacecraft are basically inert now, like bottled notes cast into a very calm ocean current. We can't hear them or guide them, but we know they're out there, moving steadily through the dark. It's a kind of peace to think that something we made has joined the natural objects of space, becoming eternal travelers. In 2015, the New Horizons probe flew past Pluto, giving us our first close look at that distant world. After the flyby, New Horizons wasn't done. It continued into the Kuiper Belt, where it encountered another small, icy object in 2019. Now it, too, is journeying outward, presently over 50 astronomical units from the Sun, more than 7.5 billion kilometers. The Sun from New Horizons' vantage is dim, about 1,000th the brightness seen from Earth. It's like a perpetual deep twilight on the spacecraft. New Horizons is on course to leave the solar system in the coming decades, joining Voyagers and Pioneers in interstellar space. It carries some sentimental items, a small amount of Clyde Tombaugh, Pluto's discoverer, ashes, a Pluto Charon postage stamp, and a message on its computer. Someday, long after it stops transmitting, New Horizons will quietly pass through the heliopause into the starry galaxy beyond. It will likely wander the Milky Way for millions of years, a tiny ambassador turned silent drifter. Not all space journeys are distant. Closer to home, the International Space Station circles Earth once every 90 minutes, gliding through the night sky often visible as a steady bright star moving slowly overhead. On board, astronauts experience 16 sunrises and sunsets each Earth day as they orbit. When they look down at Earth, they see a silent panorama, lightning flashing without thunder, auroras shimmering with no sound, city lights twinkling beneath. Many ISS astronauts have remarked on the profound peace of viewing Earth from space. No borders, no noise, just a delicate blue marble floating in darkness. The overview effect they experience is often described as a sense of unity and calm, seeing our planet as one whole. While the ISS itself has the hum of machinery and life support, to an outside observer it traverses the sky in complete silence. The crew, when not working, have been known to simply gaze out the window at Earth and space, soaking in the tranquil views as a form of meditation. As missions end, some spacecraft are left in graveyard orbits or sent to burn up gently. Dozens of satellites have been moved to a higher, quiet orbit around Earth once they're retired. There they will orbit for centuries, slowly perturbed by gravitational tugs, but largely in peaceful limbo. Others, like the carcasses of moon missions, still rest on the moon's surface, exactly where they landed or crashed, untouched in the vacuum. Even the Apollo lunar module's descent stages remain at their landing sites, along with instruments and the famous plaques. We came in peace for all mankind. On Earth, we have wind and erosion, but on the moon or in orbit, human artifacts can persist for ages in nearly the same condition. It's intriguing to think of these silent remnants. From the ISS, you cannot see them, but they're out there. A little spacecraft drifting in Earth orbit that hasn't communicated in years, quietly circling. Or a rover asleep on a dusty Martian plain under alien stars. Space can be a final resting place where things endure in stillness, a kind of eternal, quiet testament to journeys completed. Follow a grand life cycle that unfolds with incredible calm over billions of years. A typical star like the Sun will shine steadily for around 10 billion years before its hydrogen fuel begins to deplete. Our Sun is about halfway through this journey, shining reliably for 4.6 billion years already. Each day, it continues its gradual fusion of hydrogen into helium with remarkable consistency. For all the drama we sometimes associate with stars, most of a star's life is characterized by stability, billions of years of nearly unchanging output. From our perspective on Earth, this means the warmth and light that nurtures life arrives with impressive regularity. This steady radiance is the heartbeat of our solar system. A cosmic constant you can trust will be there tomorrow and for billions of tomorrows to come. Deep in the cores of stars, atoms are dancing in slow motion. The temperature and pressure are so intense that hydrogen nuclei can overcome their natural repulsion and fuse together. Yet even in these extreme conditions, fusion happens with surprising gentleness. In our Sun, any given hydrogen nucleus might wait billions of years before participating in a fusion reaction. The Sun isn't a violent explosion, it's more like an immensely patient campfire, releasing energy in a controlled, sustained manner. When we see its light filtering through our atmosphere at sunset, painting the clouds in soft oranges and pinks, we are witnessing energy that was produced deep within the Sun and took thousands of years to work its way to the surface. There's a profound peace in realizing that even the most powerful processes in the universe unfold with such unhurried grace. Some stars pulsate with a regular rhythm, expanding and contracting over days or months. Cepheid variables, for instance, change their brightness in such precise cycles that astronomers use them as cosmic measuring sticks. These stellar pulsations are like the breathing of a sleeping giant, deep, predictable, and untroubled. Other stars, called RR Lyrae variables, pulse with periods of less than a day. If you could observe one continuously, the effect would be hypnotic. A cosmic heartbeat keeping time across the void. These stellar rhythms have continued for millions of years and will continue for millions more, oblivious to human concerns, keeping their own measured pace in the vastness of space. When we look to the oldest stars in the universe, we find objects that have been shining continuously since nearly the beginning of time. There are stars still burning today that formed less than 1 billion years after the Big Bang, making them over 13 billion years old. These ancient suns have witnessed the entire history of our galaxy, steadily radiating while galaxies formed around them, while our solar system came into being, while life evolved on Earth, while civilizations rose and fell. Through all of human history and long before, they have remained distant points of unwavering light. When you see a particularly faint, reddish star in the night sky, you might be looking at one of these primordial luminaries, a cosmic elder whose light has remained constant through almost the entire history of the universe. Our perception of time changes when we contemplate the cosmos. On Earth, we measure our lives in years, but stars measure theirs in millions or billions of years. Galaxies evolve over hundreds of billions of years. This cosmic timescale gives perspective to our brief human concerns. The stars that shone down on ancient civilizations are the same ones that shine on us tonight, and they will continue to shine long after we are gone. This continuity can be deeply soothing, a reminder that we are part of something much larger and more enduring than our individual lives. The night sky is not just a ceiling of lights, it's a window into eternity, showing us a realm where time itself flows differently, more gently, with an almost infinite patience. The colors of stars tell us their temperature and life stage. The hottest stars burn blue-white, while cooler ones glow orange or red. These colors emerge so gradually over a star's lifetime that from a human perspective, they appear fixed and unchanging. A red giant star reached that state over many millions of years of gentle evolution, not through sudden transformation. As you gaze at the different colored stars in the night sky, perhaps Betelgeuse's reddish tint contrasted with Rigel's blue-white brilliance in the constellation Orion, you're seeing different phases in stellar lives, each one lasting far longer than human civilization has existed. The colorful tapestry of the cosmos unfolds in extreme slow motion, each star changing at its own unhurried pace, indifferent to whether anyone is watching. Ancient cultures around the world developed deep relationships with the stars, using their steady patterns for navigation, agriculture, and storytelling. The Greek constellations we know today are just one set among many. Native Americans, Chinese astronomers, Arab scholars, and countless other traditions created their own celestial maps. While these human interpretations differ, the stars themselves have remained the same reliable beacons. This shared human experience of looking upward connects us not just across geography, but across time. When you identify a constellation tonight, you're participating in one of humanity's oldest traditions, finding meaning and guidance in the unchanging stars. There is comfort in knowing that no matter how much human society changes, the stellar patterns above remain a constant shared reference point across generations and cultures. Patterns and mathematical relationships govern the motions of celestial bodies. One of the most beautiful examples is the orbital resonance found in many moon systems. For instance, Jupiter's moons, Io, Europa, and Ganymede, orbit in a perfect 4:2:1 ratio. For every 4 orbits Io makes, Europa completes exactly 2, and Ganymede 1. This creates a cosmic harmony, a gravitational dance that has continued for billions of years. Similar patterns appear throughout our solar system and beyond, suggesting an underlying order to what might initially appear as random arrangements. There's something deeply reassuring about these cosmic harmonies. They reveal that even in the apparent chaos of space, natural laws create stable, predictable patterns that endure across vast stretches of time. The spiral arms of galaxies follow mathematical patterns known as logarithmic spirals, the same elegant shape found in nautilus shells, hurricanes, and unfurling fern fronds. This recurring pattern spans scales from the microscopic to the cosmic, linking the smallest structures on Earth with the grandest arrangements of stars. Our own Milky Way's graceful spiral arms, though they take millions of years to rotate, follow the same universal design. As you fall asleep tonight, you might imagine yourself nestled within one of these cosmic spirals, part of a pattern so fundamental that it appears throughout nature. This connection between the very small and the astronomically large reminds us that the universe, for all its vastness, operates on principles that create beauty and order at every scale. The darkness of night itself follows a predictable rhythm that has remained consistent since Earth formed. The planet's rotation ensures that darkness arrives and departs on schedule, a reliable cycle that has persisted for over 4 billion years. Even the length of our day changes only very gradually. Earth's rotation is slowing by about 1.7 milliseconds per century due to the moon's gravitational pull. This means that in the time of the dinosaurs, a day was only about 20 minutes shorter than it is now. The night sky has been a dependable feature of life on Earth since before life itself began, a comforting constant throughout our planet's long history. As you rest beneath this ancient darkness, you're experiencing the same protective blanket of night that has sheltered countless generations before you. Among the stars, gravity weaves invisible connections that guide their motions with mathematical precision. Binary star systems, where two stars orbit a common center of mass, follow Kepler's laws with perfect obedience. Some binary stars have been circling each other for billions of years, neither approaching too close nor drifting away. Their orbits are cosmic examples of balance and stability. In some systems, 3 or more stars orbit together in complex but precisely choreographed patterns. From our vantage point on Earth, most of these multiple star systems appear as single points of light, hiding their intricate gravitational dances. Yet these hidden harmonies continue night after night, year after year, millennium after millennium, celestial timepieces keeping perfect rhythm across the ages. The atomic elements that make up the stars follow their own orderly pattern, the periodic table. Each element has a precise number of protons, neutrons, and electrons, arranged according to fundamental physical laws. These same elements, created in stellar furnaces billions of years ago, now compose the planets, the oceans, the air we breathe, and our own bodies. There is a profound unity in knowing that the carbon in our cells was forged in ancient stars through perfectly ordered nuclear processes. The cosmos doesn't just contain order, it creates it, building complexity from simplicity according to consistent rules. As you drift toward sleep, remember that your very existence is evidence of the universe's tendency toward pattern and structure, a living testimony to cosmic order. Light itself travels through the vacuum of space with perfect consistency. Every photon moves at exactly 299,792,458 meters per second, no faster, no slower. This cosmic speed limit has remained unchanged since the beginning of time. The starlight that reaches your eyes tonight has traveled through the void in strict accordance with this universal constant. There's something deeply peaceful about this reliability. The laws of physics that govern light's journey across billions of light years are the same laws that determine how sunlight filters through your window in the morning. In a universe of change, these fundamental constants provide a framework of dependability, an underlying structure that remains steadfast through cosmic time. The seasons that pattern our years arise from Earth's orbital constancy. Our planet's axial tilt and its elliptical path around the sun create the gentle rhythm of spring, summer, autumn, and winter with remarkable precision. Though weather may vary, the astronomical foundation of our seasons is unwavering. The winter solstice will always mark the year's longest night in the northern hemisphere. The equinoxes will always bring days and nights of equal length worldwide. This celestial clock has ticked reliably for billions of years and will continue long after we're gone. There's comfort in this cosmic timekeeper, a reminder that beyond our human calendars and schedules lies a greater cycle, a natural rhythm that continues regardless of our attention to it. Space might seem intimidating, but there's a certain serenity in its expanse. Between the stars, interstellar gas exists in a state of extraordinary thinness, often just a few atoms per cubic centimeter. This is a vacuum more perfect than anything we can create on Earth. A realm where matter is so sparse that particles might travel for years without encountering another. In this great emptiness, light travels unimpeded for trillions of miles, carrying ancient starlight to our eyes without distortion. Rather than seeing this emptiness as cold or forbidding, consider it as space giving everything room to simply be. Planets orbit without interference, light journeys without obstruction, and cosmic bodies follow their paths without resistance. There's a profound peace in this gentle accommodation, as if the universe created just enough emptiness to let its contents move and breathe. The night sky has been humanity's first calendar, first clock, and first navigation system. Ancient civilizations around the world looked to the same stars we see tonight, finding in them both practical guidance and spiritual meaning. The Polynesians navigated thousands of miles of open ocean by carefully observing the positions of stars. Egyptian farmers knew when to plant by the heliacal rising of Sirius. The Maya built temples aligned with astronomical events like solstices and the movements of Venus. These connections between human culture and the cosmos stretch back to our earliest days as a species. When you gaze at the stars tonight, you're participating in one of humanity's oldest and most universal practices, finding your place in the universe by observing its gentle rhythms. This shared human experience spans cultures and millennia, connecting us with countless others who have looked up in wonder. Throughout most of the universe, gravity is experienced not as a sudden force, but as a gentle, continuous influence. Objects in orbit are in a perpetual freefall, creating the sensation of weightlessness. Astronauts on the International Space Station aren't beyond gravity's reach. they're simply falling around the Earth in perfect sync with their spacecraft. This state of continuous falling creates not chaos but perfect order, allowing moons to circle planets and planets to circle stars in stable, predictable paths. There's something profoundly soothing about this aspect of gravity. It doesn't jerk or jolt, but guides everything in smooth, curved paths. Even black holes, despite their intense gravitational fields, don't suddenly pull things in. Objects spiral gradually inward along mathematically elegant trajectories. Gravity, for all its strength, works with a gentle touch. The cosmic background radiation that permeates all of space has been cooling and quieting since the beginning of time. Once an intense, searing energy, it has now faded to a whisper, just 2.7 degrees above absolute zero. This faint afterglow of the Big Bang bathes everything in the universe, a gentle cosmic cradle that holds all of existence. Scientists detected this radiation first as a subtle static in radio telescopes, a soft cosmic hiss present in every direction. There's something deeply calming about this ancient light. It has been traveling for 13.8 billion years, gradually cooling and stretching, with the expansion of space itself, now reduced to the softest of touches. As you rest tonight, imagine this oldest light in the universe surrounding you, a gossamer veil of radiation that connects everything in existence to our shared cosmic beginning. The planets in our solar system move with such mathematical precision that astronomers can predict their positions centuries in advance. This celestial clockwork continues regardless of human affairs. While empires rise and fall on Earth, Jupiter steadily completes its 12-year orbit around the Sun. There's a special peace in knowing that tomorrow morning, Venus will rise as the morning star exactly when calculations predict, neither rushing nor delaying. The orbital mechanics that govern these movements were established billions of years ago and will continue billions of years into the future. In a world where so much seems unpredictable, the steady paths of the planets offer a reassuring counterpoint, a reminder of nature's underlying dependability and the reliable rhythms that continue beyond our daily concerns. Stars don't live forever, but even their endings unfold with astonishing gentleness measured against cosmic time. A star like our Sun will eventually expand into a red giant over billions of years, so gradually that if you could watch the entire process, it would seem like the slowest of breaths, an almost imperceptible expansion. Later, as it sheds its outer layers to form a planetary nebula, the process takes tens of thousands of years, violent by human standards, but a mere moment in stellar time. These nebulae expand outward at walking pace, their gases diffusing into space with meditative slowness. In their centers, the remaining stellar cores cool over billions of years, their heat radiating away into the cosmos in the gentlest of diminishments. Even in transformation and ending, the universe demonstrates patience and grace, giving every process exactly the time it needs to unfold naturally. To a close, remember that these gentle rhythms continue their steady patterns as you sleep. There's comfort in knowing we're part of this grand, peaceful cosmos, a place of remarkable order and enduring beauty. If you enjoy drifting off to these cosmic facts, please consider subscribing to Space Girl AI for more immersive space experiences. Your support helps us create more ambient journeys through the stars. Thank you for joining me tonight, and may the quiet cosmos bring you peaceful dreams under its watchful stars.